MS Ramaiah University of Applied Sciences.
Hello students, let us discuss construction of half adder and full adder circuits. Aim of the experiment is to design and verify operation of half adder and full adder circuits. Adders are combinations of logic gates that combine binary values to obtain a sum. They are classified according to their ability to accept and combine the digits. There are two types of adders. Half adder. It is a combinational circuit that performs the addition of two bits. This circuit needs two binary inputs and two binary outputs. Full adder. It is a combinational circuit that performs the addition of three bits, two significant bits and previous carry. Half adder logic diagram and truth table are as shown here using basic gates. Half adder logic diagram and truth table are shown here using XOR and AND gate. Further, expressions for sum and carry bits using K-map reduction are also shown. Full adder logic diagram using two half adder stages and an OR gate is as shown here. Truth table, K-map based expressions for sum and carry bits of full adder are shown here. The apparatus required for this experiment are trainer kit, connecting probes, IC 7408, 7486, 7404 and 7432. Procedure for verification of adders. Verify the gates. Make connections as per the circuit diagram. Switch on VCC and apply various combinations of input according to the truth table. Note down the output reading for half bar full adder and sum bar difference and the carry bar borrow bit for different combinations of inputs. Conclusion. The half adder and full adder circuits are constructed using K-maps and the logic diagram is verified experimentally for the truth table.
Hi students, name of the experiment is verification of half adder and full adder circuits. Aim of the experiment is to design and verification of the operation of half adder and full adder circuit using basic gates and XOR gates. Now, the apparatus required for this experiment is digital IC trainer kit. So here you can see the digital IC trainer kit on which we are going to perform the experiment. So here at the top you can see a set of knobs, so which are used as inputs and outputs. The knobs which are there in the black color are used for inputs and the knobs which are there in the red color are used as the outputs. And also at the top of the red knobs you can see a LED bulbs which represent the output. If LED bulb is on, then it represents the output is logic high, and if the LED bulb is off, it represents the output is logic low. At the same time, you have a controllers for the inputs, so you can change the input from 1 to 0 or 0 to 1. That can be done through the toggle switches which are presented here. So now whenever the toggle switch in the top position which represents the input is logic high, and whenever the toggle switch at the bottom position it represents it is a logic low. And at the middle you can see there are 4 IC bases on which we are going to place the IC, and you can here see there are 4 IC bases, 1, 2, 3, 4, and each IC base is used to place an IC. So now each IC base consists of 16 slots, 8 slots are at the left and 8 slots are at the right. So now also you can see there are few knobs which are there in each IC base which represents slots of each IC. So for example, the first slot is represented or internally connected to the knob number 1, and the second slot is connected to the knob number 2, and it continues in the same way. And also you can see the red color knob and black color knob at every IC base which are used to power up the IC. And here at the bottom you can see two knobs which are there to check the continuity of the patch cords. ICs. So these are the ICs which we are using in this experiment. So this is a IC 7404. It represents the NOT gate and it consists of 6 NOT gates, single input NOT gates, and this is 7408 IC, and which consists of 4 dual input AND gates, and this is 7432 IC, and which consists of 4 dual input OR gates and patch cards. So these are the patch cards which are used to connect the circuit. Now let us start the connections. For this experiment we require one AND gate, one NOT gate and one OR gate. Now let us place these ICs into the IC bases. First I am taking 7408 IC, which represents the AND gate. Before placing this IC into the IC base, make sure the notch of this IC should be directed upwards. Then place this IC into the IC base and close the lever. The IC slot is covered by only 14 pins and the last 2 slots are remaining free. So now therefore the pin number 8 and pin number 9 should not be used in this experiment as the slots are left free. I will take one more IC, that is 7404, which represents NOT gate, and make sure the notch of this IC is directed upwards and place this IC into the second IC base and close the lever. Similarly, the third one 7432 IC, which represents OR gate, make sure again before placing this IC into the IC base, the notch of the IC should be directed upwards, and place this into the third IC base and close the lever. Make sure the IC is not coming out. Now before connecting the patch cords into the IC base, check the conductivity of each patch cords by connecting these patch cords into the conductivity knobs. So in order to do this, first switch on the power supply to the IC trainer kit, then place this patch cords into this conductivity knobs. If you get a beep sound along with this LED bulb is on, that means the patch cord is working properly. Now remove this patch cord. Do the same procedure for the remaining patch cords. Again, placing this patch cord in this conductivity tester. Again you can see the beep sound is coming as well as the LED is on. This represents this patch cord is working properly. Similarly, you have to do the same procedure for all the patch cords which you are using for this experiment. Let us connect the patch cords as per the circuit diagram. So now before connecting the circuit, I am connecting VCC and ground of every IC. So pin number 14 of this IC represents VCC. I am using red patch cord, and pin number 7 of this IC represents ground, and it is same for other ICs also. So therefore I am using a red patch cord again for pin number 14 to represent a VCC, and pin number 7 I am connecting it to ground. Similarly, for the third IC base, pin number 14 is VCC and pin number 7 is ground. So now as per the pin diagram, we have to choose the inputs of AND gates properly. So now the first IC base represents AND gate, the second IC base represents NOT gate, and the third IC base represents OR gate. Now let us start with AND gate. So now as per the pin diagram, pin number 1 is input. The input is connected to the input knob 1, and I can consider this as A, and pin number 2 of AND gate is considered as one more input. So this is connected to the input knob 2, and I will consider this as B. Now the output of first AND gate, that is pin number 3, is connected as output. I will connect this to knob number 3. This represents carry output. Now pin number 4 of AND gate, this is the second AND gate, is connected to input B here. Pin number 5 is connected to an output of the NOT gate, that is 2. Pin number 2, it is which represents output of the NOT gate. Now input of this NOT gate, that is pin number 1, which is connected to the input A, which is here. Now the output of AND gate is connected as input of the OR gate, that is pin number 1. Now third AND gate, see here pin number 10 I am considering as pin number 8, since I am not using pin number 8 and pin number 9, as the slots 8 and 9 are left free. So therefore after 7 I will consider pin number 10 or knob number 10 as a 8. So therefore this is the output of AND gates and these two are the inputs. Now I am considering input of AND gate as per the pin diagram, and which is connected to the output of NOT gate, that is pin number 4 of the second IC base. Now input of this NOT gate, that is pin number 3, which is connected to input B, I am connecting here. Now one more input of the AND gate is directly connected to the input A here. Now pin number 10 of this, or pin number 8 we can say, this is the output of AND gate, which is connected as input of the OR gate, that is pin number 2 of the third IC base. Now output of this OR gate, that is pin number 3, is connected as output, and which represents the sum. I am going to connect here at the pin number 2. This represents sum and this represents the carry of the half adder circuit. Now we have completed the circuit connections. Now let us verify the truth table of half adder circuit. Now before verifying the truth table, turn on the power supply to the kit. Now these are the two inputs. The first toggle button represents A and the second toggle button represents input B. Now whenever the inputs are 0 0, that means A and B are 0 0, sum will be 0, carry also will be 0. Now I will make the input 0 1. So I will toggle the switch. So now you can see the output sum is 1, that can be seen through this LED, it is on, and carry is 0. Now I will change the input combination, that is 1 0. So now I will make this high and the second one is low. You can see the output sum is 1 and carry is 0. And the last combination I will make both the inputs high high. Input B is high, input A is high. So now both the inputs are high. You can see sum is 0 and carry is 1. So we have completed an experiment on half adder circuit. Now let us design the full adder circuit. In this experiment we are going to use 3 ICs, that is XOR gate, AND gate and OR gate. This is 7486 IC which represents XOR gate, and this is 7408 IC which represents AND gate, and this is 7432 IC and which represents OR gate. Now let us place the ICs into the IC bases. So now first is XOR gate, this is 7486. While placing this IC into the IC base, make sure the notch of this IC is always directed upwards direction. So now I am going to place this IC into the IC base 1 and close the lever. Now we will take 7408 IC and make sure while placing the IC into the IC base, the notch of this IC should be in upward direction, and place this IC into the IC base and close the lever. Now we will place 7432 IC. This is OR gate, and again make sure while placing this IC into the IC base, this IC notch presented here should be directed upwards. So place into the IC base and close the lever. Make sure the IC is not coming out. Now let us connect the circuit as per the circuit diagram. So let us first connect VCC and ground of each every base. So as per the pin diagram, pin number 14 represents VCC and pin number 7 represents ground. Similarly, pin number 14 represents VCC, pin number 7 represents ground. Similarly, for the third IC base, pin number 14 is VCC and pin number 7 is ground. So now as per the pin diagram, so let us start connecting the XOR gate first. So the inputs 1 and 2 I am connecting now. Pin number 1 represents an input of XOR gate which is connected to the input knob and which represents input A. Now pin number 2 of the XOR gate represents an input B, so therefore I am connecting it to the input knob 2. Now pin number 3 is output of an XOR gate which connects to the pin number 4, which is input of the second XOR gate. Now pin number 5, this is the input of XOR gate, is connected as input, that is C. So therefore we have 3 inputs, A, B and C. Now pin number 6 of the XOR gate, which represents an output, is connected as output, it is sum. Now we will move on to the second IC base, that is AND gate. Now I am connecting pin number 1 is the input of AND gate which connects input A. So therefore I am connecting it to the input A. Pin number 2 of the AND gate connects input B. So therefore I am connecting here. Now output of this AND gate, that is pin number 3, is connected as an input for this OR gate, that is pin number 2. Now pin number 1 of this OR gate is connected as an output of the AND gate, that is 6, and inputs of the second AND gates are connected like this. Pin number 4 is connected to 4 of XOR gate, pin number 4 of XOR gate, that is here. Pin number 5 of AND gate is connected to carry in, that is here, input. And at last the output pin of AND gate, that is pin number 3, is connected as an output. I am connecting at the output knob, so this represents the carry. So if there are 2 outputs, one is sum, one is carry. So this completes the connections. So after completing the connections, let us verify the truth table of full adder. So for that, first switch on the power supply to the trainer kit. Then as I told, these are the three inputs which can be controlled by three notches presented here. So this is A, this is B and this is C, and there are two outputs. This represents sum, this represents carry. So now let us verify the truth table. So now for the inputs 0, 0, 0, the output is 0. Both sum is 0 as well as carry is also 0. Now for the input 0, 0, 1, you can see sum is 1, carry is 0. Now I will change the input combination to 0, 1, 0. So for 0, 1, 0, the output shows sum is 1 and carry is 0. For the third combination, that is 0, 1, 1. So here for the combination 0, 1, 1, you can see the sum is 0 and the carry is 1. And for the next combination, that is 1, 0, 0. So for the combination 1, 0, 0, you can see the output sum is 1, carry is 0. For the next combination 1, 0, 1, you can see the output sum is 0 and carry is 1. For the next combination 1, 1, 0, you can see sum is 0, carry is 1. For the last input combination, that is 1, 1, 1, you can see both sum is high and carry is high. This completes the experiment.
At MSR UAS, we spark your imagination unlike any other.